And now it is my big honor to invite our first keynote speaker for today. And he is, according to Clarivate, a highly cited researcher, which means that he is in top 1% of the most cited researchers in the world. He works both in United Arab Emirates and in Malaysia, but he was born in the very heart of Buddhism in India. So ladies and gentlemen, it is Mohammad Jawaid, please.
Okay, assalamu alaikum and good afternoon to all of you. After the coffee break, I hope that everybody is excited to listen. So today I'm going to talk about what the discussion we done in the panel. So I'm going to discuss about about the sustainable materials for three sectors. I will talk about the food packaging, I will talk about the building materials and defense application. So I'm taking a big area, so maybe I will little bit go fast, but I will pause for the translator. So basically, before going into that one, I just give the brief overview about my university. That's called the United Arab Emirates University. They call himself the University of the Futures, and this is the one of the oldest universities in UAE, and they have the almost the 17,500 students, and they have the now presently that is the 5th Arab topmost universities are there, and they have the 50 bachelor programs, 41 master programs, and doctors programs are there. And beside that, they have another lot of research centers are there, and they have the strategic area of research is the health, space, water, digital, material science, and emerging humanity, socials, and economics. And they have research productivity like other universities, and they have also collaboration with the different universities of the world, and they have they have also academic excellence and research excellence, and these are some slides. I'm passing that because they already, so this is one of my student group. It's long ago in Malaysia before the lockdown. So most of them is at presently doctors, they are assistant professor or associate professor already there. So we will basically, today I'm going to talk about the output of one of our 3 years research on the sustainable packaging materials. That is one of the case study we done on the food packaging, how we will have to develop a compostable market. When you look into the packaging industry, there are different types of packaging materials we are using for different purpose. And in that, if you look into that, the 37% of the packaging product made from the rigid and flexible materials. And there are, that all the materials are causing the greenhouse gases, and they have the 31% of the plastic debris in the marine environments originate from the food and beverage industry, which we are using in daily life. And it say that the 8 million tons of the plastic leak into the oceans, which is equivalent to dumping the content of the one garbage truck into the oceans every minute. And this is going to be increased to the 2 garbage per minute in 2030s, and 2050 it's maybe the 4 it's going to increase. And there are a lot of agro-waste materials available in the most of the countries all over the world in different forms, and that is coming from the food waste, that is coming from the vegetable, that is coming from the crop. And they are the non-product output of the productions, and materials can be benefit, economically if we can utilize these bio-based materials. And this is animal waste, as I say, food processing or different plant-based materials are there. Why basically? All the packaging materials are already available into the market. So basically, why we need this biodegradable packaging materials, So why? Because this is a large market at this moment, growing that one, and then it's trigger, as I say, the awareness of the consumer. They are looking for the biodegradable materials, trigger them around worldwide, and the negative effect of the presently using the packaging materials that is made from the non-biodegradable materials. And The growth further fueled by increasing, as I say, the environmental regulation by the different countries. They say no more single-use plastic, you know. A lot of countries already implemented that things. And this is multi-billion business at this moment. Everybody who is looking to make money, they have to jump into this business. And negative effect, if you look into the marine, there are a lot of negative effect due to the plastic is going on. So I try to show you some photograph here, how they are taking the plastics, and this is one another, the seabirds, and in the cow. They are taking the plastic, what you throw into the garbage. And this is basically the project. While I'm working in Malaysia, we've done a big project with the UK partners, and we have this project is an industrial-based project. So we have a lot of partners from the academic and industrial partner in this, and we have also the commercial partner is Tesco. So basically in this, we have developed packaging materials from the oil palm empty fruit bunch. As you know that the Malaysia and Indonesia are two countries which are the 95% the palm oil produced by this country. And they have 40 to 45 million tons of the bio-waste they are throwing after the extracting of the oil. And this is recently, I just take the photo in UAE, you know. UAE is also have a lot of the what you call that, the dead palm trees, and they are also have a huge amount of the bio-waste in that country. And this is that photograph taken in Malaysia. You saw the huge amount of this what you call the fruit bunch is coming out of from the palm oil industry. And our concept is very simple concept. You have to take the fiber from this fruit bunch and make into the pulp, and you have to convert this into any shape what you want that. So if you look into that one, this is a pulp, and this is the what you call that's the lunch box or anything. So this is on the basis of the design what you want to develop. You want to make a plate, you want to make a cup, anything you can do from that. This is I'm just passing. So there are two types of methods that can be used for making a pulp molding that one. It can be the wet method, it can be the dry methods. And this is our trial we done in Malaysia. There is one company, Eco Premiums. On that, we done the trial. We make the pulp in our labs. After doing a lot of research, it's not the simply this pulp will come. We done almost 6 months or 1 year basic research, looking all the properties and all these things. And we come on to the final product. And as we are talking, we need to move it from the lab to the industry. So we taken this pulp into the industry. So this is a pulp molding industry. They have a starting point is the pulverizer tank. You have to put in this pulverizer tank your pulp, and here you can modify. Like for example, you want that oil-based product, oil-resistant product. You want the water-resistant product. Anything you can mix here with your product. You want coloring. You want the green colors or anything you can do there. And here that it will go to the pulp slurry, which pump into the holding and mixing tanks, that one. And from there it moved to the pulp molding place, where if you look into that one, there is a panel, and this panel is what we call that control the pressures and temperatures. And this is the what called the mold. Here it's a lunch box. You can change whatever the what you call the mold you want as per your requirement. You can ask with the molding persons, they can design the product for you. And the first product we make this product, which is the lunch box. And why we make this one? Because this is one of the toughest, because it's a what we call the cap and base, both is that one. So it's very difficult to make it that. So first we tested this, and we find out all the positive effect. There is no blur, there is already smooth forms and well forms are there. So we succeeded making the product by using our lab-based pulp. And we also done the second trial by making another product. So we tried the simple product, the plates. We try, you look into that one. And this research, because it's a joint research between the Malaysia and UK, so similar thing we are doing the parallel research in the UK. So they also try to make that same type of product with the oil palm biomass, but their product is not much, so they are facing some problems, in making that mold. So we visited to the UK, and then we look what exact problem, and we find out there the what called as the pulp molding design is not right. So we designed the what call that the new mold design in the Malaysia, and we send this what call that the design to the UK. And then after that, you look that they get a very good product from the same materials what we done into the Malaysia. And we have also, I don't know, able to play the video. Yeah, this is a small video. If the people who don't understand the pulp molding process, so this is the lady is coming on to the final product, you know. And this is, she's checking manually that the quality of the product, is it the quality of the product is right or not. And this is the pulp molding machines, you know, it's auto control machines. By the panels, you can see all the parameters, and this is working auto mode. So this is, you look that one, the product is coming down, and here if you look into that one, the pulp is coming from the slurry, which I show you the initially. It will have a two-way process. One, they hold the pulp, and the second, they press it, you know. You look the process. So this is go back. And this is the basically slurry, you know, that the which we send through the pulp there while putting that one. So this slurry, the one form, they take it, and the second, they press it. Okay, so we also analyze the life cycle assessment of our productions, you know. So we want to know that really it's a biodegradable method are there or not. So we analyze all the data process from the pulp molding, the electricities, and the what you call that in the micro plants, preparations of the tanks and everything, what they consume that one. And this is the data we get from we have expert from the UK who given us the data, all that, and they have and the small scale plant. And we try to look into the real applications of this product. So we try to put into the what call that's the fruits and what we call ours. And also we develop in this, there is a what called the biodegradable plastics, you know. So this plastic is not a normal plastic. This is a cellulosic based plastics, and this is 100% biodegradable plastics are there. And we test with the different product. We test with the chicken, and we test with that one, and we also coated, you know. This the tray we also coated, because within this research we have also the antimicrobial, the product we developed from the plant-based materials. So we also coated, and we look the performance of the meat contaminations and the shelf life of them, that how much it's going to be affect from the normal food packaging materials available in the market, and what is we develop that one. And we find a lot of them the positive effect. So we done with the different what call the meats, and we look into how many days it take to spoil, and what's the difference between the normal packaging and our packagings. And we pack like a commercial one. We put the what call the fruits and all these things into that, and we look into that the suggested fridge condition, what the hypermarket is doing that one. And we compare. We also do the consumer awareness in the Tesco London headquarter. We ask the consumers that this is a normal plastic punnet they use for the mushroom, and this is ours. So we take the samples from the what call the consumers. You look that one. This is the different packaging we done, and this is the final product what we developed. So this is, you look into that one. This is a cellulosic based material. This is 100% biodegradable material. Even the ink we use is a bio-based ink. So it's everything in this product is a 100% biodegradable materials are there. So this is another, some photograph is there, and we done the survey, and we try to find the consumer's opinion on our product, and we find out that 85% of the consumers are happy with our products. This is the ratio. We taken 180 consumers to look into that one, and this is another. We develop a seal tray for vegetable veg. And beside that, we have also done, because the pulp molding is not a normal process in the industry using. Very few industry are using that one. Another one method, they are using the injection molding, thermoforms or extruders and all these things. So parallelly, we also use this biomass for mixing with the biopolymers, and we make that one we have a lot of basic research we done. So I'm just sharing here the final result, on the basis of the industry. So we make different formulation with the biopolymers, with the biomass, and we find out what are the, what called the optimum ratio we can get from it. And then we have to develop a final sheet from it in the industry, industrial partner, make it that on the composite sheet. And this composite sheet we fold into the, and we try to do the trial of the product by using a different technique. So we done by vacuum forming in the UK, we find out it's working very well. We done in the multi-vac machines, also it's working very well. And we done into the normal hot press, also it's working very well. And then we try with that, making this tray later on. You saw that with the others materials, with that one. You look into that, the front portions and back portion, there is no any painting or anything, but it look like very shining and all this thing. And this is a 100% biodegradable tray. So these are the some of the prototype I'm showing here. And there are a lot of regulations, You cannot just say that this material is biodegradable materials and you can say, no, you need to be standard for that one, If you want to send into the abroad for export and all these things. So if you look into the European market, this is 13432 is that is standard in the Europe. And even I check into the Russia, they have the earlier, at this moment, I don't know, but earlier they are also accepting this is standards in the Russia. And what are the requirement in this standard? You need the 4 point in that. One is the packaging material and its organic component are naturally biodegradable. Second thing is disintegration of packaging material take place in the composting process for organic waste. And third is it not going to give you any negative effect to the soil or anything, and it does not influence the quality of the compost. And beside that, there are also a lot of worldwide. This is the STM standard used in the US. There is a Vincote used in the Australia, and there is a DIN Certo used in the Germany on the basis of how much percentage of the biodegradable materials you have that. On the basis of that, it's going to be done. And there are different certifications worldwide. Different countries have different certifications are there. And I try to look into the case of the eco-labeling. For the time being, Russia have no own standard for that one, but they are using this eco-labeling, that type 4, and this, they are also following the ISO 14025. They are following that one. And these are they ask, I saw some survey in Russia, they show what are the consumers, what are would you trust eco-label on packaging if it plays? So you look at that one, there are anybody certifications, some percentage are doing that one, and their manufacturers are 20 plus. So this is the one survey they done. But how many people they use, I don't know. This I just taken from the internet, this one. And this is the eco-labeling. They call it Vitality Leaf, only eco-label 1 in the Russia. So at this moment in your country, this is the system, ISO 14024, ISO Guide 65 they are using at this moment. And this is the video, I don't know, means it can be play or not. This is in the Russian language. Can they play that very small 1 minute, We can do that one? I don't know that this can go or not. This is the one, what you call the YouTube information that give you on the, later on maybe you can try to go into the YouTubes and you try to find this link. They have given the informations about the eco-labeling in the Russia. Just a moment. It's not working. Yeah, it's working, okay. So this is, if I look into the global market, the global market of the packaging materials. So the global market of the packaging materials is growing. It's a 3.9 billion tons of the foods are produced annually with 1/3. And this one, if you look into the market, that it's a 1 trillion, means that going by the 2025. So as I say in the initially, it's a multi-billion business is going on. And this is the one of the Russian packaging industry chairman of the board of directors of Eco Technology. He listed down that what are the flexible packaging sector. They say tougher market condition for single-use plastic, focus on develop reusable packaging, increasing productions of the packaging options, smart packaging develop. these are the some of the things, and if you look into the future of biodegradable material, the food and beverage is the highest, what called the sector, they are taking it that one. And trend and impact, there are a lot of countries are going on to the zero plastic waste, and they have the establishment, there are trend between the consumers, and all these things are going on. These are the some survey we done in the Wales, UK, and what are the impact of this research? You know, this is benefit changes that will happen in the real world and creation of new IP. We already done the what you call the IP of this one, and changes in the regulations as per the government, and new standard for assessing a product, and influence a trade organizations. And as you know, everybody, what are the links to the SDG goal? So we have almost 1, 2, 3, 4, 5, 6, 7, 8 SDG goals we are fulfilling through this research. And technical barrier, of course, in every research there are some barriers, there are some limitations are there. So barrier performance to the grease is strength, cost, as I say, and end of the life structure are some of the challenges which need to tackle. These are the some photos of our research team, and we also done a startup company from this research. That company name we put into the fiber strong, that company. So this company is registered in Malaysia, and we try to what you call that waste to wealth slogan, we taken it that one, and we try to teach the people what are the current global problems with this plastic, single-use plastic we are using, and this is the present global solutions to replace this plastic material with biodegradable material, reduce the food waste, eliminate the toxicity in the packaged foods, and participate in the global demand for biodegradable materials, which is going to be 160 billions by 2027. And this is the product you already saw in the slides. And our technology, we have the IP for these technologies. We already developed own pulp molding, what called the design for the materials, because this can be, pulp molding can be differ from the materials to materials. And this is our strength and our target to achieve this eco-labeling, because in Malaysia there is a serum, similar like I show in the Russia, they are also doing the eco-labeling of the products. And impact of our, that create the new implements, turn agriculture waste into the economic viable, and reduce amount of plastic to landfill. And this is the timeline of our gaps, and these are the some of the photos we done for pitching with different companies in the Malaysia to aware about that our products and all these things. And this is the different photographs I'm just sharing to you. And we have already, if you want to go into the detail of this research, because I don't cover here the basic research. So if you want to go into that one, we already published a lot of works from this project. So these are the some of the papers published from our groups on the different topics from this research. Second topic, I'm going on to that one, the food to the construction and building materials, you know. Like especially the people who come from the tropical region here, very happy with the building construction here. Even the temperature outside is -10, -20, but inside of the building we feel very good, you know. So most of the people do not understand what is the reason behind that one, you know. So I just want to give you some reason about it. So this is the insulating materials they use as a core materials in the wall of the building. Because of that, you don't feel much, you know, the climate change in the building due to that one. And I try to look into that one, what are the materials they are using into the Russia, you know. So this is, if you look into that one, they are using the non-biodegradable material, polystyrene foams, minerals wools, and polyurethane foams, which are used in building to insulating and effective acoustic insulation properties are there. And there are other products is also available in the market. And one of the most parameter of that one is thermal insulating material. The material which you are going to make it, they have a thermal insulating properties are there or not. So we done in our research, and this is one of that the building materials, the requirement in the Russia, I try to get from that one. They have to, they call GOST 707699. So this one, when I tried, 99 is the year. So recently I saw they have 2022 also. They have some amendment into the regulations and all these things. So we try to make the bio-based insulating materials, you know, instead of, as I saw, put into the slide about the synthetic materials there. So I try to develop the bio-based materials. So we use the biomass, that is the oil palm biomass available into the Malaysia, and also the sugar palm. So sugar bagasse or sugar cane, you can call it that one. The waste material is a bagasse. So we try to use it, that one, and we try to solve that, what are the material, insulating materials we can develop from this one. So we done a lot of basic research of that material. We done the mechanical property, thermal properties, but mainly we analyze, these are the some methodology and all these things, so I cannot go with due to the time constant. So in our objective, we analyze the mechanical property, thermal conductivity property, acoustic properties, and all these things, and we try to find out that one, is it our material is suitable for insulating materials or not. So we find out that one, I'm just going to show you the final the information. So we find out that there is a STM standards, STM standard C208. This is for cellulosic based insulating mat. An acceptable value is the thermal conductivity for, if your insulating board is 13 mm, you must have a less than 1, So if you look into that one, most of our composite, bio-based composite, this is a pure bagasse composite, this is a oil-based composite, and this is mix-up of that composite. It shows the value is less than 0.6 or something, that one, so which is acceptable as per the standards of the what called the STM standards, which is required for insulating based materials. And we tested the acoustic property. We also find that these several parameters we use on the basis of that one, and low range frequency we also find into the acoustic properties of our bio-based materials. And from all the objectives, like if I just want to go into the last one objective, that overall study the thermal behaviors and the sound absorption of hybrid composite from agro-based source, promoting environmental friendly solutions in the wall building materials. And we also, before coming to the UAE, we also work with the KNAF. So this is a narrations of the wall, you look into this one. So if you do not understand, so this is the insulating material beside the solid wall, existing plaster and timbers, and they have this type of buildings they are making. So because of that, you feel comfortable in this type of the building. So we also done this work with one industry in Malaysia, and until now we don't publish the work, but we are going to publish soon this work. And there is also, we've done a lot of publications from this work. So if you want to know more about this one, you can have to look the different publication in the good journals we done on this research. So these are the few more publications from this one. And the third and last topics I'm talking about, how we can use these bio-based materials also in the defense applications. So one of the PhD student, we try to develop that bio-based, and we call this the coir fibers, the coconut fiber based bulletproof jackets. That is what we call that's the going to replace the Kevlar and synthetic fiber, which is existing using into the what we call that one. So if you don't understand what are the defense materials that is using for that one, so this is a common. If you look into the police, they are using the body armor vest, especially to protect themselves from the fire, and this is the protective shield they use in that one. And this is one helmet, so they have also the ballistic helmet, they use it that one. So this is the functional materials, consist of two or chemically, and they have fiber-based composite widely used in the different application. It can be in the aerospace, automotive, marines, and different applications. Because of the high specific strength and the stiffness are there. Some of the research we are already done on that one, but we don't done the bulletproof jacket from the bio-based material. So we try to done. We look into that one. Earlier of the research, we look into some literature work. So we saw that the people have coated the graphene oxide to the plant-based materials. So we done the comparative study without the graphene nanomaterials coating and with that one. So both we done it that one, and we have hybridized the Kevlars and natural fiber-based materials. But we look into the literature, we saw that some of the peoples have already done the research, but nobody's work on this research on what called the mixing with the Kevlars with the coconut sheet. And we try to do that one, and we look that one. As you know that there is most of them is a petroleum-based product at this moment using for the bulletproof jackets and ballistic applications, and this one also the Kevlar have enormous amount of carbon dioxide into the atmosphere, which is that one, the imperative to find an alternative fibers to the Kevlar fibers, and overall fabrication and the cost will improve. And we have tried to hybridize this natural fiber, because 100% we cannot remove this Kevlar fiber. So we try to the certain amount of the Kevlar fiber replace with the natural based material. So we have different objective in this research. First, we try to select which fiber we use, because there are different types of natural fibers is available into the market. So which natural fiber is suitable for the bio-based materials, and then we have to examine the effect of hybridizations of this coconut sheets and the influence of adding the GNP on the mechanical, thermal and other properties, and the main properties of the ballistic applications. And we have to look into the compare with the graphene nanoplatelets quoted, and that the without one we have the objective in this research. So first, methodology, another thing, this is the material. So this is the coconut sheet, it taken from the natural plant materials, the coconut, it's that available. So we taken, and this is the Kevlar plain 2D Kevlar fabrics, and this is the image of the SEM image of that materials. We fabricated by using normal methods in the lab, and we have used this technique, that one, we taken that one and we mix up that GNP, and then we have added the epoxy and GNP, and we taken into the hot press, and we mix with the hardener, because the epoxy what we are using is the thermoset resin, so need the hardener for curing it, that one. And we make different types of samples without Coccus nocifera, without Kevlar for compare, and then we have a hybrid, what we call the mods are there. And we have different fabrication, and we done the ballistic test experimental. There are two types of tests do for ballistic. One is the low velocity, and another is the high velocity test. And first we analyze that one, the selections of the natural fiber using AHP models for body armoring applications, and we have need to look into that. These are the properties we need, and we have taken the data from all the natural fiber based materials, and we analyze it, you know, the comparison matrix criteria and all these things. We try to do that one, and after that we came on the conclusion that these are the different result overall ranking on the basis of that one, and we find out that one, from the sensitivity analysis, we find out that among the 7 criteria, except the tensile strength and tensile modulus, remaining the 5 criteria show that Coccus nocifera coconut sheet is the most promising material that can be used for the ballistic applications. In the primary research, we done it that one, and we done normal research, because we also need to publish paper from that one. So first we done some basic research to analyze the mechanical properties and effect of GNP, and look into the mechanical properties, thermal properties, and what we call that's the ballistic properties. And SEM analysis, we look into that one, how the fiber and matrix have interfacial bondings are there, and is it the GNP have improved this one, or what happened was we can look into through the FSM image of the tensile fractures. And these are the moisture absorptions behaviors of this one, physical properties. We also look into that, the physical properties of these materials. We also look into the ballistic properties, and we have damage analysis. We have also need to analyze the damage. It came in during the ballistic analysis. And we have also another, because we have 2 comparative research. One is without GNP, another is with the GNP. So we also analyze the damage analysis of these materials, and we have also looked into the effect of this one on the dynamic mechanical analysis. This is another one properties which will give you the behavior of the mechanical property with the thermal analysis. This is very good equipment for analyzing the glass transition temperatures and all these things. So we try to analyze all the properties, and also we look similar things with the graphene nanoplatelets on the thermal performance of that one, and we look into the dynamic mechanical and also the analysis of this material, and then later on we compare all the properties of these materials and effect of graphene nanoplatelets we done on that one. And we concluded, because I will just going on to the conclusion from this one. If you look into the last one, that one, the Kevlar can be effectively replaced with the coconut sheet in optimal GNP loading of this, because we done 3 types of loading. We done 0.25, we done 0.5, and we done the 0.75, and we find out this one is the best one, is which can be replaced. And after that, we develop a prototype, because the main problem with the researcher, we do the research, but we don't make a prototype to look into the exact application of that product. So we given the name of our product, we call it techno-economic hard body armor. With one of my students, he is now associate professor in one university. So this is our brief descriptions of the innovations. So basically, this is a multi-layer hard body armor system which protect the soldiers against the high kinetic energy projectile, which is as per 7.62 mm calibers bulletproof according to the NIJ level 3 standard. There are different standards worldwide. And what is the unique about these inventions? So basically, if you want to look into the ballistic, that one, this is a multi-layer. So they have ceramic plate, they have Kevlar, they have the AI alloy. So only what we done, we just replace this Kevlar by using a coconut sheet, because we cannot change the technique and all these things because it need to protect from the bullet. So our target is to just replace the non-biodegradable materials by using a biodegradable materials. And we look into that one when the proposed coconut sheet multi-layer hard body armor meet the requirement of NIJ standards or not. So we find out NIJ standard is a 44 mm trauma. When the bullet will go there, they have to, if penetrate more than 44 mm, then you cannot what call the fulfill. So our case, it just come 26 mm. So we fulfill the requirements of that standards. And what are the compositions or process of this one? So if you look into that one, they propose hard body armors, ceramics, composite, metallic layers, and the ceramic is well-known materials for ballistic applications. And we have the impact energy carried by the projectile, and this 3 layer will join together by polyurethane adhesives, and this one have a NIJ 0101.04 standards, the multi-layer, and the Roma is basically the where you put your what call the ballistic for testing that one. I will show you that we have the setup what we done. So this is the blunt trauma of coconut sheet-based multi-layers. Armor is 26.5, one which is less than the maximum allowable blunt trauma. And in the case of the CNS, means the coconut nucifera sheets multi-layer, have a 44% of the fabrication cost we save compared to the Kevlars, that one. And this research have been proven that the coconut nucifera sheet can be a most promising alternative to the Kevlar-based materials. And this is the highlight of technical problem solved, because it's a Kevlar is a petroleum-based material that can be replaced by agro-waste materials, and this is associated with the environmental issues and also with the cost of the material, because as you know, a lot of countries cannot buy a bulletproof jacket for their army and others because of the cost effective, and most of the countries are not making it, And additional description, how we make it that. So this is a flow chart. If you look into that one, the flow chart of this techno-economic body armor, what we given the name. And this is the real bullet testing we done on that one. We have there is institutions in Malaysia called STRIDE under the Defense Ministry of the Malaysia. So I have one student there. He previously graduated under me, PhD, and he is also co-supervisor of my student. So we done that one. So this is the real bullet, and this is the fitting of that there, and this is whole setup are there, how you are going to do as per the standard. And these are the test sample. We also collected the test samples after the what called the testing, and we look into that one and we measure it. How we measure? We measure here how the depth of indentations happen into our samples. And we have also make a table to show the result. And funny thing, while we are making this hypothesis of that, we don't assume that coconut sheet will work 100%. We feel that certain percent of coconut sheet we are going to replace. But fortunately, the result will give that 100% coconut sheet also can be workable for this research. And this is, we calculated the costing, as I say to you, 44%. So we calculated on the basis of the cost in the market of all the materials, and we find out that 44.43% is the reduction in the cost of the materials happen in this manufacturing. And we have also, because when you do the patent, you need to what called the compare with the existing patent. We do not find any patent which is exactly related to our patent have done in anywhere in the world. And this is the design, the current patent, prior patent, and the prior patent are there. And we have the claim what we done that, So these are the some claims, and these are the drawing of our claims in that patent. And when we do this research, after that, lot of media have covered this news, So if you look into that one, we started to, first we published the news in our university website. And then after that, lot of news channels have himself taken. Some of them, it's come to me to talk and take the interview, what are the exact things are there. So they taken all these things, and we have a lot of that. Some of them I put here that even the body armor news is by the, that by the defense, that one. They himself taken that our research, and they try to give that the body armor made from part of the coconut tree, and these are the different, that one. These are the one reporter, he came and he take all the interviews from me in my office, and he have write full details of this one. So these are that, and like others, we also publish the work. So if you want to go into the looking into the basic research, because due to time limitation, I don't go with everything on that one, because to just show you that what the research we are doing into the lab, it can be possible to go into the prototype, and if you get some funder, you can be commercialized, you can make a startup company and all these things, that is possible. So research not only limited to your lab, you need to require to extra efforts that how you can move this research into that one. There are challenges. So these are the basic research we done. So we publish a lot of works from this research in the good journals, which is the worldwide reputed journals. We publish that one. And also I get a lot of award and recognitions from the research. So that time I get from that time he's a advisor of the Prime Minister of the Malaysia. So he awarded us, about this project. And my vice chancellor of that time university, he also awarded to bringing the biggest international grant in the university. And also I get the excellent academic award. I get the gold medals in the ICANN show there. And these are some photograph is there. So this is the photograph, and we also participated in the exhibition. So we also get the gold at international. And lastly, I'm thankful to all my co-researchers and the PhD student, master student who work on this project, and all the funding agency. As you know that without the funding agency, sometimes we have very good idea, but idea cannot implement in the research if you don't get the funding. So I'm thankful to all my Malaysians or international industrial partner, academic partners, which make it to be happen. Thank you so much.
Thank you, Professor Jawaid. Actually, you do have your brothers and sisters from Malaysia, as you know. Yeah. Can you wave your hands, people from Malaysia? Wow, thanks for coming. So we have around 6 minutes for questions. There's a question. Professor Amin, please.
Thanks for this nice presentation. I really enjoyed. Only a small question.
Yeah.
In 2017, when I was working with biodegradable packaging, we had some issues with mold and fungus, especially bacterial contamination also. What is your solution?
Regarding the content in the plastic?
Yeah. No. Your biodegradable packaging can be contaminated by fungus or mold and also bacteria.
Yeah.
What's
So basically, the solution we done we done the coating of antimicrobial, that's the plant-based materials. We developed that one. So that material have two benefits. One is going to protect you from the bacterial and all the infections, that one. And also the second thing, these materials are doing the increase of the shelf life of the product. We already done. I don't show here the research, but we already done that research. And also we look into the toxicity of the materials and all this thing. We look into that.
Yeah, but there is an impact on the water vapor permission or something like that?
Yeah, of course we don't look into that research on that one, because we work with the hypermarket. We take the materials like meat or veggie or fruits from the hypermarket, and we put into the normal condition, and we
Okay.
put with our conditions, you know, that one. And we find out that shelf life is 2 to 3 days is increasing in case of the meat and vegetables, that one. So these are the research paper, we already published that one. And we also look into the toxicity of that materials as per the FDA requirement that we
It's
done in
important.
that one.
And the last subject is the price, the market. If you want to have a comparison between the plastic-based material and bio-based material, what's your opinion? The price is a very big challenge for us.
This is the biggest problems in the price-wise. When you go to sell your biodegradable materials, most of the people are not ready to buy from you. That is because when the industry is coming, industry is looking the cent. So they don't bother about the environmental, they don't bother about your health conditions or anything, they only look into the money. So it's very difficult task, especially for the developing nations. I look into the Malaysia, and at this moment I'm looking in UAE, also the same condition, lot of non-biodegradable materials are selling. I have, and we are facing that. Even we make the fiber strong company, and we have the products and everything, but when you go to the costing, I remember that is Euro Plastic Limited one. We done the pitching with that company, he's agree, everything done, but when we go to sign, there is an issue of the money, that one, they say, no, we cannot purchase on this amount because we cannot sell in the market. So that is the government initiatives and government support, as I say into the panel talk, that the government initiatives and the government support needed for the industry at initial stage. And if the bulk product, as moment, if you look into the biopolymer industry is very limited, like even in Malaysia, we import from China or Thailand and other. In Malaysia also there is no biopolymer available. UAE also no biopolymer industry is available. And when I try to buy in the UAE, I have to pay the more cost of that because it's coming from the China. Malaysia is nearby, but the UAE is far away. So it's depend upon the demand, you know. So if the demand is coming more and the more amount will come, the price will going to be down. That can be done, but at this moment, this is a big issue. The bio-based material are not cheap. Bio-based materials are costly than the non-biodegradable materials. So we need, as aware citizenship, we say we don't want to buy. I want to buy this one. So if you started that thing, industry will come that. Or the government say, okay, from today onwards, no single-use plastic. Everybody will follow that, you know.
Yeah, thank you very much, Professor, for the wonderful presentation and a very good topic. You had very good topics. However, as a consumer on the market, when I go to buy anything, it's mostly, I don't look at the type of packaging material. What is influencing me to buy, I would say one of them is like the color of the material that I'm looking at. And these packaging materials you have shown us, they have in two colors. Recently I saw it was in kind of white, and then the other one was a little bit dull. So have you considered using bio-based chromogens that are biodegradable to give these packaging materials beautiful appearances? Because if a young child is gonna buy something packaged, it's 90% they're going to be influenced by the color of the packaging material to buy it. So have you considered trying to use bio-based chromogens to give these packaging materials a very
the
good appearance?
First question you related to the how you will identify the packaging and all these things. Because of that, as I say, there is a standard, you know, that standard is coming. So if you can go to the UK and US, and here also the eco labeling is going on. So if your product is fulfill that requirement, they have to put the logo. So on the basis of the logo, you know that this product is eco label, the product are there. So one of the standards, and related to giving it's the what call that the beauty of the product to attract the consumer. For me, it's the beauty is not needed, you know, basically that one, because we are looking on that one. But if you want, you can need to find out certain types of material. In the market, they have a colorful materials are also available. But the main concern for me is that because most of the packaging material we use with the food. So how that materials are going to behave with the packaging material, that is need to be researched, you know. that one. Of course, there is some materials available with the FDA approved one, that one, so you can use. But generally in this one, I prefer myself, that one is called the natural materials. You don't want to make any changes in that material, plant-based material. What I show you into that one, we don't use any color, anything, you know. On the basis of the plant-based materials we use, it gives the color himself, that one. So we need to teach the children. It's not to make them attractive, you know. The better thing, we have to teach our children that what are the difference between the bio-based materials and how it's going to affect your future life and all these things. That is more important in my concern, that one, you know, instead of giving the beauty to the product, that one.
But according to one article that I read in the Journal of Economics and Marketing, it said that 80% of consumers, they buy a product not only because of its content.
No, means I understand your point. It's need to make a good packaging, you know, attractive packaging. What you are saying, I understand that on the base of beauty. Of course, consumer, when we go to the market, something even cheap, but it's a very good look and all these things we attract. So similar that thing, people are doing. If you look into my product with the packaging and putting the logos and all these things, you give the beauty of that product on the packaging design. Sometimes you find some product even very difficult for you to open the packaging, you know, and you struggle to open that one. So need to be because of that we are coming with the smart packaging, you know. Smart packaging we have to do. So that I agree that we need to give that good packaging look, you know, not on the base of decorative. The packaging look, of course, that is the packaging. There are nowadays a lot of packaging engineers are coming in the market, you know, who know how to make attractive packaging. Because of that, you look into the cosmetic industry, it's changing wider on the packaging, you know, how they pack it and all this. Similar, the food industry also need to come with that type of the packaging techniques and all this to attract to the consumers. Thank you.